Hi everyone, John here with another project video. So I've been doing solar for just over a year now, and I thought I'd just show a little preview of what I've done to make my system cost effective and also very efficient. Now the first thing to note is that my system has things that work directly from 12 volts DC and things that work from 120 volts AC. Alright, let me just do a quick show. So right here is the battery terminal is connected to this board, and you have the neutral and the positive. So the positive leg goes through a 10 amps breaker. Alright, and then to the switch. The switch is just basically there just in case I need to just do some work on the system. I can disconnect the system. Alright, but the switch, the fuse is really there for the safety though, however. Alright, and then so it goes to the 10 amps fuse and then back to some wires, and it's practically invisible to some extent. Then I use the plugs that are rated for 240 volts AC. I use these for my 12 volts items because I don't want to get a mix up or confusion between things that work from 12 volts and things that work from 120 volts. So I made sure that I use two different types of plugs. And this is another one. Alright, so things that I use on 12 volts DC are things like my laptop computer. What happens that the battery is not working, and I had to end up just use it through the AC side. But what I did, I found a way where I was able to just convert the plug, the plug, so I can actually work it directly from the 12 volts instead of 19 volts from 12 volts, because the battery would have produced about 12 volts. This is just a car cigarette lighter charger. I use to charge my phone for the USB purposes. I use this most of the charge the phone. Alright, but the laptop works directly from 12 volts. Alright, so I don't know if you can see the screen, but it's loaded up now. And as I said, this works directly from the 12 volts battery. So I just connect a little extension card to it, and I connect it to the speaker socket to the plug, and that's why I work the laptop. Other things that I use from 12 volts are like my 12 volt LED bulbs that I talk a lot about. This is a normal LED bulb that I bought, and I converted it so it can work from 12 volts. Because basically when I checked the price for a 12 volts LED bulb, it would have cost me 4,000 Jamaican dollars for one, and I spent less than $1,000 and made 4 of these bulbs. Alright, and I recently just made a little stand for it, works with 3 lithium batteries. And alright, let me just, so I can actually just put this in. So you can see there. And one of them here, which goes right to the bathroom area. This one that's in the living room, and this one that's on the veranda. Alright, and these are actually the switches for them. That's normal switches, and of course the house is wired normally, so it doesn't look anyway. When two persons come, they don't even know that these are DC items. These are actually my solar setup. I recently upgraded and put this LED tube bulb in the room, and it has a little regulator, so to control the brightness basically. So I can just put it, this is the low setting, alright, and this is the high setting. Alright, and I also have one of these outside, and this right here. They're controlled by the same regulator, so 1 and 2 controls the inside light, and 3 controls the outside light. And my favorite thing is this fan that I made. So it works directly from 12 volts. Basically, it's a car pump motor converted. It's just so I can convert things. I can actually connect the blade to it. Alright, and I use a buck converter to limit the amount of power that's going to it, so I can actually use a buck converter to adjust the voltage as well. You can see it looks just like a normal fan. Alright, there's now on its highest setting. So the main reason for having items that run directly from DC is the fact that the inverter has to do what is called a conversion. They have to convert the DC from the battery to AC. Because of course, DC means direct current. So basically, the voltage is going straight, while AC means alternating current. So the current is basically going up and down, going from positive to negative, 0 to 120 volts, 110 volts. All right, and so in order for inverter to do that, it has to use a lot of power. So there's a power loss in the inverter because of that. So, for example, now when I used to use my normal fan, once it's a normal fan, it basically I can only get about 2 nights of use to this. While with this one, I can basically use it continually straight through the day, straight through the night, and there's no work. It only consumes about roughly on the speed that I use it on mainly, it's only consumes about less than 15 watts of power. My lights, each of them are rated at 5 watts, apart from the LED tube bulb, rated for 5 watts. Alright, so these are about rated for 5 watts, but however they only draw about 2.5 watts, and some of them less. Alright, because on DC they actually consume a little less power. Alright, and the laptop also, instead of have to convert the AC, so the inverter be converting the DC to AC, and then the charger now would be converting back the AC back to DC. So there's a power waste twice. So I just connect it directly to DC. Alright, and so it's a lot more cost effective, and also to charge a phone as well. Why would I also convert the DC from my battery to AC and then convert it back to DC to charge a phone? I just convert it straight from DC. Alright, so the AC side of my system is run through the inverter, and of course between the inverter and the battery there's a 40 amp fuse, and the inverter now goes through this breaker panel box. It's designated breaker, and there's one for the plug, and that connects back now to these plugs. So that's right. So the main things I really use though from the AC side of the system, things like light here, DVD player, we got a TV. Well, I have to connect the DVD now, but it's not connected. And I have a small travel iron rated for 350 watts at 110 volts. Alright, and sometimes I'll put this to charge as well. And I'll soon convert this so I can to charge it from DC instead. Right, but the iron is really the main thing I use, because one of the things I have to understand now when thinking about going solar is you have to first think about how can you save, and so that's why I'm doing all this. So what I've done is